The question is of GP, right? They are saying it's a GP. So when you will see what is the question, let S be the sum, P be the product, and R be the sum of the reciprocals of n terms in a GP. So when we don't have the GP, so we take the general GP as AR square, AR cube, and up till A raised to R. The last term will be A times R raised to the power n minus 1. Now, why the last term, the R has a power n minus 1? Because if you will see, how many terms are there? There are n terms of GP, n terms. So first is A, then AR square, AR cube, and so on. If you will see the third term, R has power 2, 1 less than 3. Then fourth term has power of R as 3. Fourth term has 3. Fifth term has 4. So obviously n terms has n minus 1. R is the power, right? So this is the general GP. Now what they're talking about, that S be the sum. Sum of the GP, sum of n terms of GP, we have the direct formula, which is A times R raised to the power n minus 1 over R minus 1, right? This is the general formula of sum of n terms of GP. P be the product. P be the product means when we multiply all these uh, terms. So if you will see that A times A times A times, how many times you have A? You have n times. So it will not be NA. You are not adding them. You are multiplying them. So whenever we are multiplying something with the same base, so power will get added. So 1 plus 2 plus 3 plus, so power will get added. So 1 plus 1 plus 1, how many times you have power 1? N times. So it will be A raised to the power n. Now you are left with R times R raised to the power 2, R times 1, R raised to the power 1, R raised to the power 2, R raised to the power 3, and R raised to the power n minus 1. Now, if you will see everyone, that the base are same here. So power again will get added in multiply. How many powers you have? You have n minus 1 powers. So here you can apply the sum of the n terms, n minus 1 terms of AP. So you will apply the sum formula for the AP, which is n minus 2 bracket 2a plus n minus 1 times d. But we have, this is the general formula to add the terms of n terms of AP. AP we are talking about arithmetic progression. So because we have n minus 1 terms, so this will become n by minus 1 over 2. 2 times A is 1 to 2 plus n minus 1 minus 1 times 1. D is also 1. That is the common difference. So when you solve this part now, so the power of R will become n minus 1 n over 2. Okay, so this is P, the product. Now let's talk about the, so this is required, this is required. Now let's talk about the R. So R is the sum of the reciprocal of n terms. So what terms we have to take? We have to take the reciprocal of these terms. So which is 1 by A, 1 by AR, 1 by AR square, 1 by AR cube, 1 by AR cube. And last term will be 1 by A times R raised to the power n minus 1, right? So when we take the sum of these terms, so let's say sum 2, this is the R actually. So when we apply the same formula for n, sum of n terms of GP, so we have A, this one, common difference 1, that is R raised to the power n minus 1 over 1 minus R. But R is 1 by R here. This is this over 1 by R minus 1. Okay. Now, what is required? I am taking that only. Otherwise, all things I am removing it. So now what they are saying in the question. So this is required, this required, and this required. Like I am writing P here as here because I want the space. Okay, now we have three things. Now, what is the question? That LHS is equals to P square times R raised to the power n is equals to S raised to the power n. So we are taking LHS only, which is P square multiply R raised to the power n. P square means squaring of this one. So P square means A, 2 multiply n is 2n times R raised to the power n minus 1 times 2, this one, right? Times R raised to the power n. What is R? R is this one, complete 1 by A times 1 minus R raised to the power n minus 1 over 1 minus R minus 1 raised to the power complete n. Just we have to solve it. So solving this, 2 cancels out. So it is this R raised to the power n minus 1 times. Let's take the power with every part of the bracket. So it will be this times. Let's solve this. So it will be this. We just have to solve it and nothing else we have to do. So after solving this, what we are having, and I open the bracket and multiply n minus 1 is n square minus n into, this is this I am taking here because everything is in multiply. Now I am again taking the LCM here, and this, if I'm taking LCM, I'm taking in the numerator, so it will be r over r minus 1 minus r. Okay, and everything has the power n. Now let's solve this. If we will solve this one, the base are same and they both are in division. So a raised to the power 2n minus n is a raised to the power n. R raised to the power n square minus n. Now n multiply n is n square. This is left. Okay. Now nothing is there. So what we do, because these two base are same, we can add the powers. Okay. So this cancels out. What is r raised to the power n square and r, so this is cancels out. So you are left with a raised to the power n 1 minus r raised to the power n whole n over 1 minus r raised to the power n. This you are left with. Now if you will see in the right hand side, you have s raised to the power n. If you will see the right hand side of the question, it will be s raised to the power n. So we have Sn. If you will see Sn raised to the power n, it will be equals to a raised to the power n over r minus 1 raised to the power n. If you will see here, if I will take minus common from this part, so the values will be same only, right? Because values will be same. Let's do one thing. Let's take minus common here. So if you will take minus common here from the numerator and denominator, so it will be 1 minus r raised to the power n over 1 minus r only, or after taking negative common. So if we will take negative common directly here, so it will be like this. Negative and negative negative cancels out. So here, if you now you take the power n, so it will become 1 minus r is to the power n over 1 minus r. So if you will see, these two things are same. So p square times r is to the power n is equals to s raised to the power n. Okay. So it's a little complicated process because we have to find out for the sum, product, and some of the ratios of the terms, and then we have to put it in the left hand side and do something in the right hand side and prove them equal. Okay, so that's it everyone. Thank you so much.